engineer in maybe the worst way possible by trying to get K3S like 4 or 5 years ago, before it was as stable as it is now, to run on a Raspberry Pi for a miniature self-driving car I was building for work, which sounds ridiculous in retrospect, but I promise we had a reason for it. And the way I explain Kubernetes now is really heavily influenced by that experience, by my experiences teaching bootcamp grads intros to Kubernetes, and my experiences handling some comms-related kerfuffles for the Kubernetes project, wherein I learned just how little developers tend to know about Kubernetes, even when their app is being deployed on it. So if you want to get a hold of me later, my Twitter handle is Dixie3Flatline. You can also try emailing me at work. I would not recommend trying that. I'm not great at replying to emails. So let's go. First off, why should developers even care about Kubernetes? The answer is because you are probably going to have to touch it eventually. Even if you're not developing with Kubernetes locally now, it's increasingly likely that the application you're building will be deployed with it. So it's similarly increasingly likely that you're going to be expected to be able to test it locally so that there aren't any surprises. At the very least, you're going to be expected to understand containers, as the shift from like monolithic architectures to more of a microservices situation moves some of the responsibility for standing up and making infrastructure decisions from exclusive the ops team to more of a shared responsibility, which is kind of the whole point of DevOps, right? We're trying to like meet people in the middle there rather than just chucking things over the fence. But nobody's asking you to become an expert. There are entire people whose jobs it is to be an expert in Kubernetes. The average developer does not need to do that unless you want to pivot towards specializing in Kubernetes, which a couple people in the crowd here have done. You really just need the basics. We'll start with defining what Kubernetes actually is at a surface level. It is an open source container orchestration tool. And a container orchestrator is a tool that automates the management and deployment and scaling of containerized applications. While it is possible to do all of this by hand, it is slow, it is unreliable, and it is a massive pain. You don't want to have to do it. We've all heard that Kubernetes is difficult to learn. This is like a long-standing thing that we're kind of trying to get away from, and part of that is talks like this and tracks like this to make it feel more approachable. But I promise you that if you're in a situation where you need Kubernetes, it is much harder to go without it than it is to just learn it. You can think of container orchestration in terms of a container ship. It's a super common way to explain the way this works. Kubernetes and other tools like it, there are other things that do this, like Docker Swarm and Mesos. It's the thing that dictates which shipping containers go where on the barge in relation to other shipping containers and what goes in them. So it's the person at the dock with a clipboard, right? These collections of organized containers are called clusters. So container orchestration means that there are now a whole bunch of things that you don't have to worry about anymore. Scaling your application happens with much less effort. So say you get hit with a ton of traffic, your app goes viral somewhere, and suddenly it's very, very popular and you need to handle it. In most cases, that is a one-line change in whatever tool you use to define your cluster and what your application looks like on it. You just bring up more replicas, right? Instead of going to your cloud host and provisioning more servers, deploying your application to those new servers, testing that application on those new servers, and configuring all of your proxies again. That's a much bigger pain, at least for me. You don't have to worry about deploying those individual servers anymore or testing them. Kubernetes just spins up another replica. And a lot of security and networking concerns do get abstracted away from you. That is not to say that Kubernetes is inherently secure. It definitely isn't. It solves some security concerns that you have with other ways of deploying and scaling applications, but it introduces some new ones. So do not fall prey to the long-standing meme that Kubernetes is secure, because it's not. Same goes for networking. In some ways it's easier, in some ways it's harder. You are making trade-offs here. So complex Kubernetes may be, but that's because of how much previously manual labor it is doing for you. The operational overhead of getting going can be a pain, and it does require specialized knowledge to put it up there and to maintain it. But once you get to a point where you really, really, really need a tool that's powerful, like your team or your org should have the resources to handle that. I am of the opinion that not everything needs Kubernetes. In fact, a lot of things super don't need Kubernetes, but it never hurts to be prepared with kind of knowing what it is. Besides all of that, the Kubernetes community is massive. It's really, really big. It's really, really friendly. It's made up of me and the track hosts and a bunch of other people in the crowd here, and hopefully the rest of you who are new and just went to the 101 workshop yesterday. We all want nothing but to build this better and extend it and make it easier for others to come help build it better. So I hope you join us. If you have a question ever after this talk, 10 years from now in the process of like using Kubernetes, we have a huge online community and we will happily answer your question. If we don't know the answer to it, we know who does and we'll point you at them, which is the real power of the Kubernetes community. So come hang. Before we go further and dive into Kubernetes architecture, I want to address the big blue whale in the room. I'm glad that I included this slide because somebody asked me a question about it earlier today. Docker and Kubernetes get conflated quite a lot, and it can cause some problems. So what does Docker have to do with Kubernetes? If you are a developer, you might be used to using Docker locally for dev. This is a particular point of confusion for engineers touching Kubernetes for the first time, and one that we have underestimated before. So this is worth mentioning for the folks in the room who are touching Kubernetes for the first time and have like literally no context. Colloquially, we like to say Docker image, right? But it is really more of like a Qtep Kleenex situation. When we say Docker image, like the image Docker produces is actually what's called an OCI compliant container image. OCI stands for Open Container Initiative, and other tools can produce OCI images too. Wildly popular and also being a really important part of the Kubernetes project's history. It was the original and only container runtime for Kubernetes for a while. So unfortunately, it's a little annoying, but at this point, you kind of just have to figure out from context clues whether somebody literally means Docker Desktop, the tool you were using for local dev, or if they are referring to any old container image. But functionally, there is no difference between a thing produced by Docker Desktop and a thing produced by, like, Podman. Now you know. Hopefully that solves some confusion for the person I talked to earlier. Now that we've cleared that up, though, let's talk about the anatomy of a cluster and see where those containers end up living. So Kubernetes is extremely complex. Wow, that's fun. Oh no, I didn't even get to the good slide. There is a good slide too. Oh, what is happening? Is it my computer? I can't tell. Because it's, oh, should I kill my cluster? Actually? Here, how about I plug in my power on the other side and see if this computer is doing that thing that, ooh, it's haunted. Is it haunted? It's fine on my display.
What happens when you move to the next slide?
Okay, what year computer is this?
It's a 2015.
2015.
Yeah.
Right. Do me a favor.
Yeah.
Switch to the second port right here.
Okay.
No, the actual video out.
Oh, okay. Yeah.
Because
Oh.
And the only one I know that is definite.
Everybody get a teaser of my funny slide. I'm glad everybody actually thought it was funny, too. Yeah, just gotta... There we go. We're back. Oh! Not glitchless, buddy. I can switch laptops. I just can't use my terminal on the other one because it's an M1. You want me to try switching laptops?
I would say,
Always have a backup, yes. This is an anxious habit I picked up from Jessica Dean because she always travels with a second laptop, just in case.
I was going to say, I think now that it's been threatened with a new laptop, I think it's going to get
Okay. Oh. Okay, it's my 2015 that's cursed. It can't run. I was concerned that was going to be a problem because this laptop is old. It can't run a Kubernetes cluster and video at the same time, I guess. Anyway, sorry about that. So, Kubernetes is super complex, right? And this complexity is one of the things that can make it so difficult to teach and learn. But fortunately, you only need the broad strokes at first, and we're getting better at explaining this complexity in a way that makes sense to humans. I promise you that almost nobody is a subject matter expert in the entirety of the whole situation. Most people specialize in only a couple aspects of Kubernetes, like networking or storage or security or authorization. Absolutely nobody is an expert in the whole kit and caboodle. I doubt even the people who originally built the project are at this point because it's so different, comparably. And this diagram, or one like it, is how people usually explain the pieces of Kubernetes. I've taken this one straight from the Kubernetes docs, and it does a perfectly fine job. It's very well annotated, it's very clean, but I think it's boring and it's unmemorable, and I had a really bad idea that I have to get out, and y'all are trapped in a room with me. So you, you have to learn from a different diagram. This is Kubernetes, okay? This is Kubernetes. If you use Kubernetes already, you will understand immediately, both like architecturally what's going on here and from the vibes this dog is exuding. This dog has tired cluster admin energy, like for sure. And for everybody else, allow me to explain Kubernetes architecture for you with the help of this chihuahua standing on 8 cheeseburgers. This whole situation here is your Kubernetes cluster. Each cluster needs to contain at least 2 things, a control plane and a worker node. The worker node contains the pods that make up your containerized application workload, and that is the bare minimum. That's what you need for a cluster. In a production environment, you would see one control plane, maybe across multiple machines, managing multiple nodes. Maybe each node is a dedicated machine to maintain high availability. So the control plane is the thing that manages what's going on with your nodes and your pods. It's responsible for managing everything to do with your application workload and with the cluster itself. The control plane itself includes several smaller components as well. It's got the Kube API server, which is responsible for exposing the Kubernetes API for use, etcd, which I am now pronouncing correctly in this talk, which is a key value store for all of your cluster data. The Kube scheduler, which takes care of assigning newly created pods to nodes, and 2 controller managers, which are responsible for managing a whole bunch of control logic, and one of them is cloud-specific. The exasperated chihuahua is your control plane. So a node is a worker machine responsible for managing one or more pods. The node contains all of the things the pods need to operate, like your container runtime as well as the pods themselves. Nodes are made up of 3 parts. The kubelet, which is responsible for babysitting your containers by making sure that they're healthy, kube proxy, which is for networking, and a container runtime on which your containers ultimately will run. There are different container runtimes with different advantages. Most cloud providers default to containered, which is actually pronounced containerd, and each stack of burgers here is a node. A pod contains all of the things that make up your application workload in the form of containers. In the case of this image, our application workload is what I assume is a McDonald's dollar menu cheeseburger. So we have containers for a slice of cheese, ketchup, the burger patty, onions, pickles, the bun. Those little like dehydrated grated onions are incredible, and I wish more places had them. Because we've got friends coming over, we've told this cluster that it needs to maintain 4 nodes of 2 pods each for a total of 8 replicas of the same cheeseburger. Thank you for letting me quell the screaming of that particular brainworm. So, now you know what makes up Kubernetes architecturally, but you want to play with it on your own. Deploy some stuff, scale it up and down, good news. There is no reason to go straight to cliff diving into the ocean here. There are tools that abstract away some of the more nitpicky parts of running Kubernetes, like dealing with some specific like networking and security concerns that just do not matter if you are doing it locally for fun testing playtime, but you do absolutely need to worry about in prod. These tools, however, do not generally prevent you from digging into the API if you want to, so you can still experiment. So we are going to stand up a little cluster and deploy something really common to it, Nginx. I will say that since I've had to switch laptops, the demo itself is running on this one. I have slides for it just in case of this, but at the end, if my laptop wants to give me a second chance, I will switch back over to it so we can actually poke at the running cluster. So for my cluster, I used Minikube. Minikube is what I prefer to use when I'm just messing around on a local machine, but K0s and K3s also exist and are really cool. They are both meant for more like IoT embedded applications on like really small, low memory machines. You can, of course, also just use a full-featured managed Kubernetes service on a cloud provider like GKE or one of the 85 million ways AWS now has to deploy containerized workloads. It's truly getting out of control, and I honestly don't know what most of them do anymore at this point. I check everything on GKE because I know what it does. Anyway, for situations like this, I do prefer to stick with things that aren't going to accidentally run up a huge cloud bill if I forget to like tear down my infrastructure at the end, even if it's not exactly production ready. So you will see me have to like do some weird stuff and take some shortcuts because I'm using Minikube and not like GKE. So this is step 1. I really wish I had my computer for this that would let me show you, but anyway, I would have had to do this slide anyway because installing Minikube takes like 10 minutes on that computer. It will not be that slow for you if your computer is newer than 2015, but anyway, this is Minikube installed and starting. You can see I've set some flags here. One is to specify a driver, just to show you that you can. This used to be necessary in order to like use some particular aspects of Kubernetes on certain operating systems. So if you go to try this yourself and you're running into a weird problem where like, for instance, an ingress controller isn't working, if you're on a Mac, it's because you need to be using the VirtualBox driver. There are a bunch of other drivers that come with it. It will default to Docker usually, but there's also HyperKit and a couple of others. You can also see that I'm setting the memory that Minikube is allowed to use. which can be useful. By default, it wants to use 8 gigabytes of memory. The total available memory on this laptop is 8 gigabytes, so obviously I can't let it do that. Anyway, running Minikube start is literally all you need to get a small cluster off the ground. It's going to immediately stand up a control plane and a single node for you. You will also need kubectl, also called kube control, also called kubectl, or kube for any of those, and it has become a little bit of a clicky thing. Who says what? But it's, I'm looking at you, Quinn. But it's you say kubectl? I know officially it's kubectl because it got a little cuttlefish, but I just can't, my brain doesn't do that when I read it. Anyway, you need this tool in order to interact with your cluster directly, and you need it regardless of whether you are working locally or you're working on a cluster on a cloud. You just hand it a file called a kubeconfig, which tells it like where your cluster is and gives it the keys, how to access it. Helpfully, Minikube places a kubeconfig for you in a default location that kube control knows what to look for. So this allows us to look at our cluster, see what's going on in there, and make it run stuff. Defining what's going on inside of your cluster can be done in a variety of ways. This is also ripped from the Kubernetes documentation. If you want to just use vanilla Kubernetes, you can write your deployments and service definitions as YAML and apply them with kubectl. There are also a bunch of different infrastructure as code tools that you can use to stand up your cluster and deploy things to it. I will show you one of those later. But this is what the deployment YAML would look like for an Nginx deployment if you were to just use kubectl. At the top there, you can see a kind of deployment. That means that this file is going to create a deployment object, and its only job is to dictate what container is being deployed under what conditions and how many replicas of it need to stay online. In this case, it is 2 replicas of a container running Nginx at version 1.14.2, running on port 80. A quick note on Kubernetes objects, by the way, there are a bunch of them. A deployment is just one of them. I will also use a service object later. But there are also like namespaces, volumes, replica sets, stateful sets, a whole bunch. They all serve different purposes, and most of them are beyond the scope of this talk. Frankly, I think you could probably give an entire talk just on Kubernetes objects, just because there are so many of them. And YAML is totally fine for simple examples like this, by the way. They do, however, get really, really, really hairy if you have something vaguely complicated that you're trying to define. They get to a point where it can be kind of hard to read. It can get kind of hard to manage what's going on. You poke one thing and the whole thing falls over. I also prefer to write in a programming language if I can, so that I can stand up my infrastructure alongside or even like in my application. So because of this, I'm going to show you what Pulumi looks like instead of the kubectl approach. And I will tell you where to get this code so you can all just stand it up yourself too. Sometime tonight I will put my slides up online on Noticed, and it'll include like links to where all of this stuff came from in the Kubernetes docs. So this is what that same Nginx deployment looks like in Python. It contains the exact same information, but it's expressed programmatically, and it's a lot more dense. For me, a person who has only ever been a developer or a developer advocate and has never worked in ops, this is much easier for me to read. And I know that that's not true for everyone, but I like to not have to learn a new syntax if I can avoid it. But yeah, this is the exact same information, though instead I've got 6 replicas. Yeah, 6, and it's running a more recent version of Nginx. But to make this thing actually functional, a deployment is not enough. We need a service too. This is a service deployment expressed in Python. While deployment objects dictate what's running and how many of them, services in Kubernetes manage network access. This one, if I was not using Minikube, would stand up a load balancer for us if we were running on something like GKE instead. But Minikube does not support those. This is one of those places where I have to take a weird shortcut because it's Minikube. Instead, it is going to give us a cluster IP. That decision-making is handled by the presence of a config value that I set before actually running anything. So I got all that Python, and I want to turn it into an Nginx deployment running in a Kubernetes cluster. You just need to, in my case, run pull me up, and it'll give me a little overview of what's going to happen if I say yes, deployment and service defined, standing up in my project for this demo. Click yes, and it creates the resources for you in about 13 seconds. This is what I mean by speed running, and also what I mean by any percent, because this is not a production-ready cluster. This is like how fast can I get a cluster online and something in it. It doesn't matter how functional it is, because frankly, for like teaching somebody Kubernetes, giving them an overly complicated like full stack application is, in my experience, not very useful. It's difficult to grasp. So 13 seconds is what it took to stand up these resources in a cluster, which at first, when I started using this tool, I found it unbelievable how fast it was, and I super did not trust it. But it is there, and if this computer behaves, I will be able to poke at it. So we have all of this stuff here. It's got an output at the bottom, front-end IP. That is the cluster IP, because again, this is Minikube, which does not support load balancers, but we can still look at our Nginx deployment outside of the cluster and prove that it's online. So another Minikube oddity, I do have to do some port forwarding to be able to actually access that. But fortunately, it is a one-liner with kubectl, and we only need a little bit of information from our running application in our cluster to do it. We're going to go look at some stuff here to confirm things are up. If you run kubectl get pods, you can see that I asked for 2 pods to be up, and they are up. And if you run kubectl get deployment, you can see my deployment object, which, again, I told to keep 2 pods online. You can see it's got 2 out of 2 ready, 2 available, 2 up to date, and it had been online for 42 minutes when I took the screenshot. But what we actually need is the name of the service we stood at, because remember, that is our network access. So you guessed it, kubectl get service, and it lists the services we have running. If you grab the name of that container there, you just forward the port for the container to my local, and then you can curl it and see that Nginx is online. Now I'm going to try to get this computer up there without slides so that I can actually open up my terminal. And let's see if I just kill Chrome, if it'll go. And then we can look at stuff running. Let's find out. Yoink. Thank you. You are a peach. Let's just mirror it. There we go. So, do I still have things running? I do. So the whole cluster is still up here, and a thing I wanted to show you what I mean by Kubernetes scales fast is we've got 2 pods there, right? So say that we need this to be suddenly much bigger. You can literally just add more replicas. And update the config. It's going to say I've got 1 thing to update. Let her rip. And now there is 6 of them immediately. So this is so fast because it's such a small workload, right? It's literally just 1 deployment, 1 service. It is Nginx. But it's still, Kubernetes is a little bit more approachable this way when you're working locally with a really small workload, and it's a good starting point, right? Nginx is a thing that many of you have probably had to use in the course of doing your job. You at least know. There's 1 person raising their hand. Pardon? Is that big enough? Yeah. Let me see if I can get it. Does that go? Ooh, it's computer's starting to struggle a little bit there. Yeah, so we've got our 6 pods online, but this is a good starting point, a good jumping off point from like building something yourself, a containerized application in Kubernetes, because it can just like pull containers from wherever. You can build a piecemeal application if you want. You can also write your own application inside of a Docker container, chuck it onto a public registry, and go from there, right? So I know that demos like this aren't technically impressive, right? There's not a lot going on here. It's not very complex. I've only got 2 pieces. I don't have like database interaction or like a whole bunch of third-party stuff. I did not stand up a service mesh or whatever, but try when you're like learning something new, especially something as big as Kubernetes, not to like jump straight into the deep end. It's more important to understand like the foundational aspects of how a tool like this works, so that when you do get more complex and start adding on pieces to a demo like this small, it is a little bit easier to intuitively figure out where you're going wrong if things aren't working the way you expect. If you understand like the way the pieces of Kubernetes interact with each other, you're not going to get lost as easy. It might not be as exciting, but it is. You know, people advise that like, instead of like banging at your keyboard for 30 minutes, you instead spend like 15 minutes reading the docs. It's that. It's that. Do not just like go in blind with a wildly complicated cluster with, 15 microservices making up a JavaScript website. It's like not necessary. It's not necessary. Just do this instead. But this is what Kubernetes looks like. This is how it works at a very high level. If you would like to learn more about Kubernetes, if you want to go for like a 200 level situation, the interactive tutorials on the Kubernetes website are actually pretty good in my experience. I really, really like them. They also use Minikube, so it'll be a familiar tool. And also, the CNCF Twitch account and the Kubernetes Slack are both super helpful. The Kubernetes Slack in particular is very, very, very active. There is a getting started channel, and I cannot repeat this often enough. There is no stupid question. There is no, like, don't apologize for not knowing the answer to something. We want to help you learn as much as you want to learn, and nobody's ever going to make you feel bad here for not knowing something, because I didn't know stuff for a while, and there's still like so much stuff I don't know. So come help, and then once you're off the ground, pay it forward, answer somebody else's question that they're maybe a little bit embarrassed to ask. And now I will unplug my computer because it is still screaming, and I don't want to give somebody a motion-sensitive migraine because of the flashing on the right side of my screen. But if anybody has any questions or comments, let her rip.
Can you use Pulumi to manage Helm-based deployments?
Yeah, you totally can. There's a Helm provider. It also like doesn't really. There isn't really a whole lot Pulumi can't manage as far as like Kubernetes resources and like cloud native stuff. But yeah, I use it with Helm all the time. Yeah.
Okay, hold on.
Can you put the picture of the dog up again? I didn't get to take a picture of it.
Yeah, absolutely. Would you like the picture of the dog up with just the dog, or do you want it with the annotations? Okay. Yeah, no problem.
More questions?
That's fine. No, no, no. It's okay. You know what? The dog came from Ian Coldwater's kid was writing a talk and tweeted asking like what is Kubernetes. For people in the room who don't know who Ian Coldwater is, they are a Kubernetes security expert and also very popular on Twitter. So let's see. Let me get the dog back. But Nara, Ian's kid, tweeted asking what is Kubernetes, and I responded with that dog. I was like super hungover, but I just responded with this dog, and I was like, I can't explain it, but this is Kubernetes, and now I've explained it. So yeah, there's my preferred Kubernetes architecture diagram.
I have one question.
Oh, sure.
Is there a path of migrating from Minikube to a real Kubernetes cluster? I have found in the field that developers end up putting the stuff in, production stuff in Minikube.
If you have been building your entire app in Minikube, Minikube does have a lot of limitations that you're not going to see with something like GKE or EKS or whatever. And I would not say that you can like directly port a deployment that was intended for Minikube, taking the like shortcuts and roundabouts that Minikube requires to a full-fledged situation. There are issues that you have to consider, and some of them are those like networking problems that you saw me go through. Like those problems, you can't port that directly over to GKE. You are going to have to like use a real load balancer. Do not return the cluster IP. You can return the cluster IP, but you know, don't. Right? So then, am I wrong?
Right. Also, there's a Minikube stubs out all the storage.
Yes. Like Minikube is, it's got a lot of, it's not intended for production. It's extremely not. Use that for testing, use that for a playground. Do not you try to use Minikube for prod. It's got all kinds of issues that like cannot be addressed in Minikube, security issues, networking issues, storage issues. So don't build from the ground up with Minikube in mind.
Minikube not do peer-to-peer communications between the individual pods?
It can. I'm not sure like what, from a technical perspective, prevents the load balancer object from being available in Minikube. Gwen, do you know? No?
I use Kind.
Yeah.
Yeah. You want to repeat what people are saying if they're not on mic?
Oh yeah, sure. The question was like, in Minikube, is there not peer-to-peer connections available between pods? It can communicate between pods, but I am not sure why the load balancer object doesn't exist. Does anybody actually know the answer to that? Yeah, it does. Yeah. Good point. I think Kind handles it though, so.
Yeah, I have a related question. So
Yeah.
you're saying don't just do your entire development on Minikube, but
Yeah.
sometimes it's useful to have sort of a development replica
Yeah.
of your production cluster so you can do local development.
Yep.
So I'm curious what the story you think is appropriate there is. How do you end up building that such that you can have better developer experience for people working locally?
Yeah, so there are special considerations for Minikube that unfortunately you can't get around if you're trying to clone your production environment. I think Kind gets a lot closer to having like a true ability to clone a production environment. That is what Gwen here in the front uses. I like Kind. I'm using Minikube for this strictly because it is what the Kubernetes interactive tutorial on their website uses. So I wanted to make sure that there was some consistency there. But yeah, unfortunately, if you are trying to use Minikube as your local dev environment and you want it to be a true clone of prod, you are probably going to have a bad time. And you're better off just using Kind or something like it's a little bit more flexible. There was somebody in the back that had a question. Thank you, Josh.
Hey, thank you. So does this mean that, like, if the pod owns, that the dog will just eat the hamburger?
The dog does not get to eat the hamburgers. The hamburgers are reserved for users, which are our friends that are coming over to eat those hamburgers. Unfortunately, the dog is just there to make sure that the hamburgers exist and perhaps protect them from other dogs.
Gotcha.
Yeah, or maybe the cat.
I find that, like, using Kind, because you can use programmatically use YAML to spin up multiple
Yeah.
clusters, as well as Rancher Desktop. Additionally, you may want to add Metal LB to get that cluster IP.
Okay, thank you.
Hello.
Hello.
More of a Pulumi question rather than a Kubernetes question.
Sure.
I'm wondering if there's any good static analysis tools, since we get to use real programming languages.
Yep.
I know, like, a really basic example, I'm more practiced in CloudFormation, and so one really annoying thing, right, is if you don't set your auto-scaling group properties correctly, like, oops, I set my desired server to less than what I said my minimum was.
Yeah.
Submit the template, and then wait 10 minutes, and
For
then
it
be like,
to
oh,
fail.
You didn't do it right. So I'm curious if there's, since we're using real programming tools, or real programming languages, if there are any good tools to take advantage of that, to do this kind of checking and make sure, hey, nope, don't submit that yet. There's some mistakes.
There may be a third-party one that I'm not aware of. There's the closest thing like built into Pulumi is if you run Pulumi preview, it's going to give you an idea of what changes are happening, and some of those potential changes can cause a failure on Pulumi preview. So some of them you will know in advance if this is just like going to barf, which is good. But as far as like actually analyzing whether or not you've made like a logical misstep in your code, Pulumi doesn't do that itself. There may be a third-party tool.
Yeah.
Gwen, do you know of any? Gwen is she is an engineer at Pulumi.
Sorry, what was the question again?
Are there any stack analysis tools for Pulumi that would identify when you've made a logical error in your deployment, like setting a minimum different from a maximum in a way that like conflicts?
For Pulumi?
Yeah.
Yeah.
Like you would just run Pulumi preview to see a lot of
Yeah.
that stuff, right?
Yeah, you run Pulumi preview, and the info output should have most of the standard logs, and
Yeah.
you can also access diagnostics, run it in verbose mode, all of that, yeah.
Yeah. Do you know of a third-party tool that like goes more in depth? I don't.
No, but sometimes I cheat by going to the debugging Pulumi site on pulumi.com, and I run log to standard error, and I get a bunch of logging output, and then I use grep.
That's a hot tip, actually.
Don't tell my boss I said so, though.
This is recorded.
I'll also say that because it's a complicated stack, there's a whole industry in analysis tools.
Yep.
So look in the CNCF landscape.
Yeah, definitely.
I realize that's a bit of an adventure, but they're...
You're asking for a lot here, Josh.
Yeah. But I mean, like, because it's a complicated stack, you're actually probably going to be stringing together multiple tools.
Yep.
To look at, like, one's going to look at security, one's going to look at, is auto-scaling actually going to work, how you've configured it, and another one's going to do something else.
Oh, and you absolutely need an observability tool. Like, do not just like go pawing through logs by yourself ever, unless you like really need to double check something. Like, there are observability tools that handle that for you and make it a little bit more human readable, less messy, because the logging output can get very messy. Are there any more questions? I love this dog.
Hi.
Hi.
Thank you very much for the very nice talk, and dog is simply amazing.
Thank you.
Well, it's kind of maybe a newbie question, but
Yep.
there were comments that Minikube lacks a load balancer, and I was playing with it like literally yesterday, and there is a plugin or add-on to Minikube called Ingress. So
Yep.
you can say something like Minikube enable Ingress.
Yep.
Isn't it the same as a load balancer, or what would
So-
be your comment on that?
Nginx ingress is not quite the same as a load balancer. It's an ingress controller. But that is actually like a thing I mentioned. It was why I was setting a driver. If you are standing up Minikube and you are setting up an ingress controller, it can cause problems with old MacBooks and you need to use a different driver. But yeah, an ingress controller is a different thing, but in that case, it can like serve a similar purpose to a load balancer, so it kind of gets you there, right? It gets you the same result, but it is not the same thing as a load balancer. Any more?
We have time for one more question. Okay. Beg your pardon again?
I forget, how do you tell Pulumi to use your local Minikube cluster?
Do I have that code on this computer? Probably not. It is on this one. So my code makes that decision for me, actually, because like I knew that I was going to be doing this with Minikube, but sometimes I do this with a real provider. And so so when you are setting up Pulumi in the first place, it is going to look for a kube config, and it's going to look for a kube config in the default location first, exactly where kubectl looks for it, which is in the like hidden kube directory in your root. So it looks there, and your kube config just needs to like contain the access keys for your local Minikube cluster, and then Pulumi will just pick it up. But if you want the same like decision making I had, where like this can run on a local cluster or this can run on a remote cluster, I use a Pulumi config value. So like it's just is Minikube config require is Minikube, and before I run Pulumi up, I just set that config to true or false, and then it makes a decision from there. There's like a little if else in the bottom of my code. This particular like sample code is online in the Pulumi GitHub account in the examples repo. So just github.com/Pulumi/examples, and there's like a whole ton of Kubernetes examples in there, and this is the Nginx one. So you can just rip that code, and it will go. And I think that's it.